Hi, in this video we will be trying to understand rotational motion and laws of motion via numericals. Okay, I would be picking up numericals one by one, and that itself I would be explaining many fundamental things which are required to understand the basics of laws of motion and rotational motion. Alright, let's see how it works. A rope is wound around a hollow cylinder of mass 3 kg and radius 40 cm. What is the angular acceleration of the cylinder if the rope is pulled with the force of 30 Newton? The options are these. Alright. Now mind you, you have radian per second square and meter per second square. So you have rotational as well as linear units. Alright. Okay. Let's understand how do we do this. Now what we are interested in is in angular acceleration. Now what I say is, always whenever you want to go into for rotational, think of linear, because linear we know force is equal to mass into acceleration. We know this about linear. So similarly we can convert it to angular, that is tau is equal to, we know equivalence of mass is I, moment of inertia, and A is alpha, angular acceleration. So that's the formula for torque. And torque we also know is force into perpendicular distance. Force into perpendicular distance. That is what is torque. Alright. So we can also say tau is equal to F into R. Alright. So what's our mission? Our mission is to find angular acceleration. So if we intend to find angular acceleration, obviously it would be tau over I. Now tau we can also call it as F into R, and moment of inertia, they have already mentioned that it's a cylinder, and we know cylinder is compilation of ring. Hollow cylinder is compilation of ring, one over the other. So it is m r square, moment of inertia. So we jot down m r square. Okay, one r gets cancelled. So what we are left with is F over m r. Why not just jot down the values? Force 30 newtons. Put in. Mass 3 kg, put in, into radius 40 centimeter. Obviously 40 centimeter wouldn't work, so we have got to convert it into meter. So it would be 40 into 10 raised to minus 2. Alright, so this would be equal to, obviously this goes away, and so this straight away goes away, forms 10. Then this can go up there, so this could become this, and this can go, so we would be having 100 over 4, that is 25 radians per second square. Alright, so the option would be C. A uniform circular disc of radius 50 cm at rest is free to turn about an axis when is perpendicular to its plane and passes through its center. It is subjected to a torque which produces a constant angular acceleration of 2 radians per second square. Its net acceleration in meter per second square at end of 2 seconds is approximately, these are the values. Alright. We have been provided with a circular disc which I showed just now, which I just rolled around. Assume the radius of that is 50 centimeter. Now it is free to turn about an axis, so it turned about its axis, which was perpendicular. Axis was perpendicular to its plane. This axis, the axis was perpendicular to its plane. If I draw a circle over here, good. So radius is 50 centimeter. Now obviously 50 centimeter doesn't make any sense in SI unit, so we have got to convert it into meter. So 0.5 meter is the radius. All right, free to turn about. All right, now first of all you should know that if it is moving, as we saw, if the disk is moving this way, so it would have one acceleration this way, which we would call it as tangential acceleration, and the formula for tangential acceleration would be alpha r, or r alpha. All right, other acceleration would be centripetal acceleration. All right, now this centripetal acceleration, I would be writing it here, centripetal acceleration AC. Formula for centripetal acceleration would be r omega square. All right, so r alpha and r omega square. All right, so these are two, and the formula for actual acceleration would be root of AC square plus AT square. It would be root of square of centripetal acceleration plus square of tangential acceleration. That would be the actual acceleration. All right, so these are the things that we should be aware of while tackling this numerical. All right, now what have we been provided out of this? Alpha is provided, which is 2 radian per second square, and if alpha is provided, we know omega is equal to alpha t. What is omega? Omega is angular speed, the angular speed. So we know acceleration. See, if you again, I go back to linear. In case of linear, v by t is acceleration in case of linear. Similarly here also, omega upon t is angular acceleration. So therefore omega would be alpha t. I take it here. So it becomes, so what we are interested is in net acceleration in meter at the end of 2 seconds. So our time is 2 seconds, right? T is 2 seconds. So it would be 2 into 2 is equal to 4. All right. So acceleration would be 4. So angular velocity. So we are interested in angular velocity. Angular velocity is alpha t. Alpha provided is 2, and time provided we need it after 2 seconds. So 2. So this becomes 4 radians per second. Radians per second. All right. So we got omega, and our formula requires what? Our formula requires AC square, that is r omega square plus r alpha square. All right, so we got this. Now is it possible for us to get AC? Is it possible for us to get AC? AC is equal to r omega square, where r given is 0.5 meter and omega square would be that we found out is 4, so it would be 4 square. All right, so AC we got, so AC is 16 into 0.5, that would come to 8 meter. It would come to 8 meter per second square. All right, so AC is got. Now what about AT? Tangential. AT formula is r alpha. Acceleration given is 2 radians and r is given as 0.5. So our radius given is 0.5 meters and acceleration given is 2 radians per second, so that comes to 1 meter per second square. Alright, so this became 8 meters per, so we got this. In order to get A, what do? We do square of this and square of this. So that would come to r omega square is 8 square plus 1 square, that comes to 8 is a 64, that comes to root of 65. That approximately would be equal to 8 is a 64, 8 meter per second square. Okay, let's get into this numerical. A man weighs 80 kg. He stands on a weighing scale in a lift which is moving upwards with a uniform acceleration of 5 meter per second square. What would be the reading on this scale? So this is the situation. This is the lift. Man standing on weighing scale, lift moving up. G has to be taken as 10 meters per second square. Before we get into this numerical, there are certain basic things which we have got to understand. First thing is, a body stays on surface when its normal is equal to mg. That is the first thing that you have got to keep in mind. So when body flies, when normal reduces to 0, the body would start flying. Alright. So it is the normal which keeps the body on surface. Alright. Now, let's try and understand the situation. Now, some basic questions. When we are in lift, when do we feel light? When the lift moves down or when the lift moves up? Obviously, you feel lighter when the lift moves down. That itself means, in case when the lift is moving down, your normal is much smaller than mg. Alright, so it is moving down, so with an acceleration, so the force that is being experienced is ma. Now here, since you are feeling light, so obviously mg is greater than normal. So the equation would be mg minus n. Alright. Now, when the lift is moving up, you feel heavy, right? So you feel heavy, that itself means normal is greater than mg. Alright, since the lift is moving up with an acceleration, so it is ma. So force ma now would be equal to n minus mg, because you feel heavy, so normal is greater than mg. Here mg is greater than normal, and here normal is greater than mg. Fine. Okay, now there is no acceleration. The lift is moving up or down with uniform velocity. Alright, so what would happen is ma would be 0, so n would be equal to mg. Okay, so this is the situation which you have got to keep in mind. Now, keeping this in mind, let's progress with the numerical. Okay, man weighs 80 kg, given acceleration of lift also given. It is 5 meter per second square. Done. Now, here in this situation, we are here. The lift is moving up. So, this is our equation that we have got to follow. So, just let's jot it down. So, it is ma is equal to n minus mg. So n would be equal to, if we take mg this side, it would be ma plus mg, which would be equal to m into a plus g. Alright, so this would be equal to normal. Alright, what does our question want? The reading on the scale would be mass is 80, acceleration is 5 and g is 10. So it would be 80 into 15. Alright, which would be equal to 1200 Newton. So this would be the reading that would be observed on the scale. Alright. Let's try this out. Consider a car moving along a straight horizontal road with a speed of 72 km per hour. If the coefficient of static friction between the tires and the road is 0.5, the shortest distance in which the car can be stopped is, these are the options. Let's see how do we move about it. Few things we are supposed to know before we get into this numerical. First thing is that answers are in meter and speed given is 72 km per hour. So we have got to keep it in mind that whenever we have got to convert kilometer per hour to meters per second, we have got to multiply whatever given in kilometer with kilometer per hour has to be multiplied with 5 by 18. Like for example over here it is 72 kilometers per hour, would be 72 into 5 by 18 and the value that we get is 20. Alright, we know that 18 4s are 72 and 4 5s are 20, so it would be 20 meters per second. So this conversion factor has to be kept in mind. Alright, and if it is other way around, like meters per second has to be converted to kilometers per hour, then that meter per second has to be multiplied by 18 by 5. So we get it back. Alright, so this is one thing which you have got to keep in mind. Now, the basic theory says that force is directly proportional to normal. Now, in case of friction, it is equal to mu n. Now, we know n is equal to mg when the body is on floor. So, we can also write it as F is equal to mu mg. Now, force we know is ma is equal to mu mg. So, this mm goes. So, the formula that we would be requiring over here is A is equal to mu g. Alright, where mu is static friction. So these are the two things that we have got to keep in mind. Alright, now the situation is consider a car moving along a straight horizontal road with a speed of this much. If the coefficient of static friction between the tires and the road is this, the shortest distance in which the car can be stopped is. So now it is the frictional force which is stopping. So we are talking in terms of retardation. Alright, so since we are talking in terms of retardation, we are talking in terms of minus A, or we can write it as minus mu g. Now they have provided us with static friction of 0.5 and g that we have got to take is 10. So we got retardation which would be equal to minus 5 meter per second square. Now what we are wanting to know? We are wanting to know distance. Now, I hope you are aware of all the three kinematic equations. Now one is V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. Presumably you are aware about all these three kinematic equations. Now in this case we have got V Alright, V final velocity stopped, so V is equal to 0. Initial velocity is provided. Alright, it is moving with 20 meter per second. It was 72 kilometers per hour, which we converted to meters per second and got it to 20 meters per second. Alright, so if I jot down this equation, that is V square is equal to U square plus 2AS. Now in this case we know V, stopped, that is 0. We know U, which was provided as 72 kilometers per hour, and we converted it to 20 meters per second. So we know this also, it is 20 plus 2 is 2, and acceleration, rather it is retardation, that is minus 5, and what remains is S. Alright, so we know this. So if I take U square this side, so it becomes V square minus U square. Then I take 2A down there in the denominator, so S remains. So S is equal to V square minus U square over 2A. Alright, on substituting values, what we end up with is, we know final velocity stopped, so 0 minus initial velocity converted to 20 meters per second, 20 square upon 2 into retardation minus 5. So we end up with this. So ultimate answer that we end up with is 40 meters. The answer is A. I presume this video to be helpful for your purpose. Would be generating more of such videos. Keep viewing and study well, and take care.